All right. Well, hey Tim, what's going on? What are you doing? Oh, I'm here with Tim Uzard from Ecomech Mechanical in Atlanta, geothermal contractor. What do you got here, Tim?
We have a water furnace geothermal system consisting of a 3-ton package unit. We've got a 2-ton indoor split unit that handles an air handler in the 2nd floor attic. Over here we've got a 6-ton geothermal pool heater.
6-ton, wow.
Yeah, this bad boy right here takes the heat in the summertime that we're putting out in the yard. It takes it back out of the yard and puts it in your pool.
Cool, cool. So that just, all that does right there is just heat the pool.
Makes hot water.
Makes hot water.
That's right.
Just in the summertime?
Just in the summer. If they, it could make hot water if the homeowner chose to upsize the loops. We would have to add 6 more tons of geothermal loop.
Wow.
To handle the 5-ton home and the 6-ton pool heater.
So we got 5 tons of total cooling.
5 tons.
So
3 and 2.
3-ton package unit.
Yep.
And a 2-ton split system.
Mm-hmm.
What's the difference? How come that is bigger than that one there? What?
Well, essentially what this little unit is the bottom section of this unit.
Right. So
this upper section from here to here actually resides in the attic for that unit.
Oh, okay. So there's a compressor.
There's the compressor here, and the air handler is in the attic connected with copper lines.
Right.
Here, your compressor's here, and your air handler's here, and the copper lines are literally about 10 inches long.
Okay, no different than a rooftop
unit. Than a rooftop package unit. These units come in a vertical configuration,
right,
a horizontal configuration, and even a downdraft configuration where the compressor is up here and it blows air down.
Right. Well, I guess the reason why do we have this split system? Why don't we have one of those in the attic?
Well, they used to do that.
Right.
The reason you don't do it now is we like to keep all the water piping down in the basement or in a crawl space. If we were to put a package unit in the attic, number one, this unit weighs 460 pounds.
Wow.
So putting it in the attic, you've got some load consideration.
Right.
Also, you've got to now get your water pipes from underground in the yard through the house up into the attic.
Right.
Additionally, some of the older installations, these units were built into the house.
Oh yeah, no, I've worked on plenty of them. So
to replace it, you know, sometimes you've got to chop a giant hole in the ceiling to take an old one out and get a new one in.
Right, right.
So it just makes more sense now to keep all these mechanical components in the crawl space or the basement with a lightweight, simple to work on, simple to replace air handler in the attic. Yeah,
for the guys like me that has to work on them or actually come and replace them later on.
Yeah.
If they do need to be replaced. We were talking the other day, and they actually make a different kind, don't they?
Yeah, they make one of these in an outdoor split.
Wow.
So this is an indoor split.
Right.
It's silver. They make an outdoor split. It's basically a white box, and the pump is it's a little bit longer than this, and the pump is internal.
Wow. Okay.
So as you see here, the pump is external. The outdoor unit has an internal pump with a special temperature sensor so that if the unit's not running but it gets really cold outside,
right,
it'll turn on the pump just
to keep it from freezing up.
Water from freezing.
Right, and I guess that would be another concern with having a package unit upstairs in the attic because of the water.
Could be.
Could freeze or whatever. But
typically, if it's that cold, your system's going to be running anyway.
Right.
As long as the water's circulating to a 62-degree earth.
Right.
It's not going to.
So these pipes here, where do these actually come into the house?
These pipes circulate and they actually run through the crawl space.
Right.
And go through the front wall of this crawl space here.
Right.
We're in a crawl space / basement configuration.
Well, how deep are the actual wells?
This one has 400-foot deep holes.
400. How many?
This project has 2.
Wow. So there's 2 wells, 400 foot deep.
Yeah, we don't call them wells because inspectors take that meaning the wrong way.
Oh, okay. So what would we call it?
We call them holes.
Holes, okay.
Yeah.
So there's 400 foot holes in the ground.
Yeah.
Now, there's different types of, people talk about having holes that go in the ground straight down like this one is, 400 foot down in the ground.
Mm-hmm.
And then there's, people have a lake.
Some people, if they have a private pond or a Georgia Power lake, they can put a lake loop in.
Right.
Army Corps of Engineers won't allow it in their lakes.
Right.
And then also if you have a pasture, some cleared acreage, you can put a horizontal loop in.
Right, like a slinky thing? Or
yeah, we don't really like the slinkies because air gets trapped in those.
Oh, okay.
But that is one of the approved methods. But yeah, majority of the installations are vertically drilled because this house is in an inner city lot, not a lot of land.
yeah, it's looked like about a half acre.
This
Maybe?
is about a quarter acre.
Quarter acre,
Yeah,
wow.
It's a small lot. So,
Wow.
but our 2 holes separated 20 feet apart take up an area of 20 feet by 1 foot.
Wow. I didn't do, well, of course I couldn't see them. They're in the ground. But are they up front?
They're in the front.
In the
They're
front.
about 4 feet down. Safe from any future digging. You know, if you want to plant a tree or anything in the front yard.
No
worried.
problem with the roots getting to them.
No.
Eventually maybe, but
No, never.
Never?
The pipe material is high density polyethylene.
right.
So that's the same thing they run gas piping out of down the
Oh,
side
okay.
of roads.
Yeah.
Those large coils of yellow.
Right.
That material, it's a little bit elastic,
Right.
so it does expand and contract. It does have some play in case there's some shifting in the earth or anything like that. Whereas PVC pipe is brittle. And
Right.
you think if you hit a piece of PVC with a hammer, it would just crack.
Right.
Your hammer would just bounce.
Okay. So we're stable with the water, with the loop.
Water's good, yeah.
Now,
Actually,
go ahead.
what we've got right now, we've got 66 degree entering water.
Wow. Well, it's not that cold outside neither, is it?
No. And it, that's pretty good for this time of year.
66 degrees, pretty.
Yeah.
Now, what is the average water temperature incoming?
It'll range anywhere from 44 to 95 degrees. Most of our loops we've seen have been anywhere from 88 down to 50.
Wow.
There are some older style loops that were put in years ago
Right.
that are no longer put in, but technically they're within parameters. They still function.
Well, yeah, that goes along with everything else. If the older something is they didn't know much about it then.
It's evolved.
Yeah, it's evolved.
Yeah.
I noticed that. So we got, what did you say, 66 come in?
66 entering, yeah. Now this unit's in cooling right now because we're actually trying to pull some moisture out of the
Yeah,
house.
it's pretty humid upstairs.
Leaving temperature is 77.
77.
So we are disposing 10 degrees of heat to this water, which doesn't sound like much, but this water's flowing through this unit at 3 gallons per minute per ton. So that's 9 gallons per minute.
Wow.
It's circulating through this unit.
And that pipe's not that big neither. So it's
these are 1-inch hoses, and this is an 1.25 inches. It runs all the way out.
right. Now, down here we have 2 openings right there.
Mm-hmm.
And that would be for the hot water, right?
This is a new construction installation, so those have not been run yet. But you've got an entering and a leaving domestic hot water. those will actually tie into this water tank. It'll come off of the cold water line at the top of this tank.
Right.
Pipe in to the incoming, come out of the outgoing, tee in down here at this drain.
At the drain down there.
It's got an internal pump in the unit, and it'll suck water out of this tank, whether it's hot or cold.
Right.
Add heat to it.
Right.
Put it back in.
So you're essentially, as long as we're heating or cooling, you're making free hot water.
Yeah, yeah. It's, you know, it's merely a supplementary.
Right.
Heat. It's
right.
not this will not provide all the hot water you can ever use.
Right.
So it's merely a supplemental aspect. If the situation fits, it's a great thing to add to a system.
I think I was at somebody's house that they actually had to disconnect them plugged on their water heater, and they were. He wasn't complaining, but you know, some people do.
I've seen people take two of them and manifold them into one water heater.
Right.
There might be enough capacity if you've got all your units tied into one tank to make enough hot water.
Huh.
One unit simply won't do it.
One unit won't make all your hot water. It'll. Well, what would be? You know, is it the water temperature coming out of the unit? Well, I guess it depends on what's coming into it.
Right. It's going to give you about a 6-degree temperature rise.
Right. Anywhere
from a 4 to 6 degree temperature rise.
Okay.
So if the water in that tank is 70 degrees, this is going to heat it to 74 or 75 and put it back.
Right.
The thing is, it's doing that
constantly, so it will build it up eventually.
This feature offsets your hot water consumption by an average of 40% per year.
Right.
So, to do some simple math, this water heater, without the de-superheater, uses $497 in energy.
Right.
According to their estimation. 40% of that is, you know, not even that good with math, about $210 a year.
Right, right.
So, this feature would save you $210 of this.
Wow.
Maybe $200 or so.
Well, that's, you know, that's a couple times of eating out.
Yeah.
Now, this is a Series 5.
This is a Series 5. It used to be called the Envision Series.
Right.
When they changed the name to the Series 5, we lost the blinking lights, the analog interface.
Right.
We went to a digital plug-in computer.
Oh, yeah.
So this plug-in here is literally a Cat 5 plug-in. That gives me access with a handheld computer to see what the fan speeds are, what the refrigerant pressures are, what your water temperatures are. It'll do energy monitoring. It'll tell you how many kilowatts of energy this unit's used in a month. Some nice features with that digital interface versus the analog interface.
Right, of course.
Because the indoor splits do not come in the digital interface yet.
Right.
So as you see, it still says Envision, still has the blinking lights.
Right, right. Now, they have a different version now, don't they?
They do. They have the 7 Series unit. We've put 4 of those in now, and we're getting ready to put 4 more in. It looks essentially the same as this. This panel is gray versus blue.
Right.
The compressor inside is a true variable speed inverter compressor. It has an electronic expansion valve and a little more software inside.
Right.
That unit, one important fact is it cannot be located in a space that's over 125 degrees ambient temperature.
No attic.
No unspray foamed attics.
Oh yeah, that's right. That's right. Because we are in an Earthcraft house, and everything in this house is spray foamed.
Most everything, yeah.
Yeah. I mean, except for the floors. This is an
unfinished basement here. So,
right.
You can put them in a spray foamed attic. You got to look at the 7 Series like a laptop computer.
Right.
You know, would you operate it in a 100-degree room? Probably not.
No. Now, getting back to this 5 Series.
Yeah.
What is the SEER rating So I know you can't be accurate because of different variables, but what do they claim this? What do they say the SEER rating?
Well, to begin with, SEER stands for Seasonal Energy Efficiency Ratio.
Right.
Why seasonal? Because most air conditioners and most heat pumps sit outdoors and they're exposed to the seasons.
Right.
Our unit is not. We don't experience seasons. It's a consistent water temperature from under the ground.
Right.
So they go by EER,
okay.
Energy Efficiency Ratio. EER on this unit is rated at 40 EER.
Wow.
Excuse me, 30 EER.
30.
Excuse me, yes. 30 EER would kind of equate to about 38 to 40 SEER.
Wow. Well, that's quite a bit.
That's good. Now the 7 series unit is rated at 40.1 or 41 EER.
Right.
Which translates to about 55 SEER.
Wow. Well, that's because of that inverter compressor.
The inverter compressor.
The electronic TXV.
Electronic TXV. It's literally monitoring the space load. That unit will operate as a 1-ton unit when needed.
Right.
It can operate as a 5-ton unit when needed. And it even has the 5-ton unit, which is the largest 7 series they make, has a override feature. Let's say you're having a party. Or guest.
Right.
It's 4th of July and the doors are open and
right.
you need some extra capacity. It has a feature called Super Cool.
Right.
You press a button and it actually operates as a 6-ton unit for a 24-hour period of time.
Wow.
So it gives you a lot of capacity variations, and the 7 series units are 20% more efficient than the 5 series units.
Wow. At a 20% more cost?
Probably 60% more cost.
Wow. Wow. Well, yeah, because there is more technology into it.
A lot of technology, yeah.
So, I mean, on average, because people are watching this and they're going to say, how much does this thing cost? I mean, you don't have to say if you don't want to, but that is a question that a lot of people say that they do ask.
A good rule of thumb is $7,500 to $8,500 per ton for a system like this. Add a pool heater in there, that just adds more cost.
Right, of course. But just if somebody had a 3-ton unit at their house now, an existing house, now that's including ductwork, because if you do a system like this, you really need to change all the ductwork out.
Some cases, sometimes duct's not in bad shape and it was actually designed and installed properly.
If it was designed properly and installed properly, you wouldn't have to change. But
right.
Most systems are inadequate anyway. So, anytime you change your system out, you do need to do some duct modifications. But say a little 3-ton system, what is that? $20,000 with ductwork included.
We just did one. It was about $22,500.
$22,500.
Minor duct modifications. That was an outdoor split scenario.
Oh yeah.
Some of the 7 series installs get up into $10,000 per ton. Right.
Wow, but they still offer the tax credit though.
They do. 30% of the total cost of the job.
So that's you're cutting a lot if you're talking about doing a $22,000 job.
Another feature is the way the tax credit code is written. Anything I have to do my job is qualified under this tax credit.
Right.
So if you live in an existing home and you've got nowhere to put loops in except under that old broken driveway,
right,
you can pay me to tear out the driveway. I can put loops in. I can put a new driveway back. Loops in. I can put a new driveway back. That all falls under your geothermal tax credit.
Didn't know that.
Yeah.
Didn't know that. So if you need a new driveway,
give me a call.
Give Tim a call.
Yeah. The
now,
water heater that's linked with the geothermal unit,
right,
falls under the tax credit.
Wow.
Because it's